Here we are at example 5 from the 0.2 number 2 set of notes. We're asked to graph this following function. And in just looking at things, we're going to go ahead and start out by doing our horizontal asymptote. Our horizontal asymptote just simply comes out to be one of those three scenarios. We can see that on top we have a degree of 1, whereas on the bottom we have a degree of 2. And because we have that scenario where the degree on the bottom is larger than the top, we're just going to end up with our horizontal asymptote being y equals 0. Now when we're talking about our vertical asymptote, one thing that helps out when we're trying to determine like things like VA and these future things called holes, we'll talk about that in a little bit, are going ahead and actually factoring. So we're going to go ahead and factor the bottom. The top you actually can't factor, so we're just going to leave him alone. But the bottom we can go ahead and factor. When we do that, we have x squared minus 2x minus 3. That actually factors out to be x minus 3 times x plus 1. And so as a result, again, when we're trying to find VAs, that's when the bottom is not equal to 0. So we're just going to go ahead and take the bottom and set him not equal to 0. When we do that, we can go ahead and use that zero product property and break these up. So we have x minus 3 is not equal to 0, and x plus 1 is not equal to 0. Solving for each one, we just end up with x is not equal to 3, and x is not equal to negative 1. Now, when we go ahead and graph these, we just end up with this horizontal asymptote, 0. We have 1 at negative 1. And then 1 at 3, positive 3. Oops. At this point, now all you would do is plug in some values to kind of see, what is the general shape of this. In fact, yeah, we'll just go ahead and do that for now. So if we have x and y, that was kind of bad. Let's retry that line there. Y. Alright, we're going to go ahead and break up our x's and y's into some different, basically different segments. So we'll take, like, for example, negative 2 and negative 4. We'll try those out for the left side of that first one. And then in between, we can go ahead and go with maybe like 0 and 1. We'll change up colors too. So 0, 1. And then on the right, so now when we're looking at negative 2, when you plug that value in, you end up with negative 1 over 21. When you plug in, I'm sorry, that was actually negative 4. So when you plug in negative 2, you get a value of 1/5. When you plug in negative 4, you end up with negative 1 over 21. When you plug in 0, we end up with 3 over negative 3, which is negative 1. When you throw in 1, you get negative 1. When we put in 4, we get 7 over 5. And when you plug in 5, you get 2/3. And so we should see something. Again, this graph doesn't necessarily have to be perfect. But as long as, you know, things are on the right side of where they should be, so for example, like here at -2, we should see something that's a positive, so like 1/5 obviously, but it's above that x-axis, so right about there. At -4, we see that it's -121. In looking at that left side, it appears that there's going to be a cross that occurs. Now when we look at 0 and plot that, we had -1. Also at 1, we had -1. On the right, we end up with 4/7, so that's a little bit more than 1. For 5, we end up with 2/3. So overall, if I had to just kind of guess the shape of this image, I'm thinking that it's going to look something like this. Let's get a better one. It's going to hug. It's going to end up hugging, pass through this point, cross at some point, and then go back up and hug that horizontal asymptote. Should go through that point and hug more though. So on the left side, we should see something more like that. In between, I'm assuming, since I didn't really necessarily see any cross there, it's probably going to hug, go through these 2 points, and then go back down. On the right, we're just going to see a hug, and then go through those 2 points. So more or less, that's what we kind of, in the back of our mind, should be thinking. Now let's go ahead and algebraically prove where does that cross actually occur. So for the cross, we know that our horizontal asymptote is 0. So instead of this f of x, which again is y, we can go ahead and throw 0 in here for that y value. So we have 0 is equal to our rational function. X plus 3 all over our x squared minus 2x minus 3. And now all we have to do is go ahead and solve for x here. If we multiply both sides by this bottom, well, on the right, they just end up dropping out, leaving us with just that x plus 3. And on the left, we have 0 times anything is still just 0. And from this is pretty easy to solve for. Just comes out to be x is equal to -3. Hopefully, you actually recognize that we could have used that shortcut. Because our horizontal asymptote was 0, again, all you really needed to do was set this top portion equal to 0. So we should have seen a cross somewhere around -3. So there should have been more, this graph would have been more like this. So it's coming down, passes through that point, there's the cross, and then it hugs. Okay. So again, that is example 5 from the 0.2 number 2 set of notes.